Two of the most important parameters in designing and drilling a well for oil and gas are the well's pore pressure gradient and fracture gradient. This animation shows how pore pressure and fracture gradients change as one drills deeper into the earth, and how drillers use drilling mud to manage subsurface pressure. Pore pressure is the pressure exerted by fluids within the pore space of rock. That pressure is generated by the weight of the rocks and fluids above the porous zone. When drillers encounter a zone of porous hydrocarbon-bearing rock, the pore pressure will force oil and gas out of the rock and into the well, unless the drillers do something to counter that pressure. Drillers use drilling fluids, including drilling mud, to counterbalance the pore pressure. They adjust the weight of the column of mud inside the well so that it generates pressure at the bottom of the well that equals the pore pressure within the rock. This keeps the well in balance. Drillers measure the pore pressure in terms of the density of the mud column that would be required to balance that pressure. A plot of this pressure, expressed in terms of pounds per gallon as a function of depth, is called the pore pressure gradient. If the pressure of the mud column above a porous zone is less than the pore pressure, then the well is underbalanced. Sections of an underbalanced well can collapse, and formation fluids can flow into the well from the surrounding rock. An uncontrolled flow of oil and gas into a well is called a kick. If drillers do not recognize and control a kick quickly, the kick can lead to a blowout like the one at Macondo. Like any natural material, rock will break or fracture under enough pressure. If the pressure of the mud column above a rock formation is high enough to fracture that formation, drilling mud will flow out of the wellbore and into the formation instead of returning to the surface. This causes what is known as lost returns or lost circulation.